Here we're going to do a short lesson on solving linear systems by substitution. So if I have two linear equations, good idea to start off with is to number them. Equation 1, equation 2. Now I see I have a y by itself in the first equation. So y equals 5 minus 3x. I'm going to take what y is equal to, that 5 minus 3x, and I'm going to replace the y in the second equation with what it's equal to. So I'm going to sub y equals 5 minus 3x into my second equation, which is 2x plus 4y equals 5. So following that second equation, 2x plus 4, I'm subbing in what y is equal to. So I'm not going to write y anymore. Put in brackets and put what y is equal to, which is 5 minus 3x equals 5. Now I'm going to multiply the 4 into both those terms. So I have 2x plus 20 minus 12x equals 5. I can do a little bit of rearranging. So 2x minus 12x equals 5 minus 20. So that will give me negative 10x equals negative 15. X equals negative 15 divided by negative 10. X equals 3 over 2. So I can find the one x value. I've done a little substitution. I got down to just one letter. My original equation started with an x and a y, and I got down to just an x. Find what x is equal to. Then I can sub what x is equal to into, and you can choose one of your original equations. And it doesn't matter which one. I want to choose equation 1 because it's just a little bit easier. I want to find y now. So y equals 5 minus 3 times 3 over 2. Y equals 5 minus 3 times 3 over 2 is 9 over 2. Y equals 5 minus 9 over 2. Okay, so I'm dealing with fractions here. I'm going to turn that 5 into a 10 over 2. Subtract 9 over 2 to get a common denominator. Y equals 10 over 2 minus 9 over 2, which is 1/2. Therefore, my x and y coordinates are equal to 3 over 2 and 1 over 2. This is the point of intersection between these two lines. Okay? Second question that I'm going to solve. 2x plus 3y equals 7. X minus 5y equals negative 3. Now in this question I need to make a decision. What letter do I want to get by itself to start with? I'm going to choose the x in equation 2. Equation 1, equation 2. If I rearrange equation 2 to get the x by itself, I chose this because it had no coefficient, just an invisible coefficient of 1. So it would be easy to do. So I'm going to get this x by itself. So it would be x equals, I'm going to take my minus 5y over to the other side, becomes a plus 5y. So it's negative 3 plus 5y. There is my equation 2 rearranged. X is by itself, which means I can take it and replace the x in the first equation with what x is equal to. So I'm going to sub x equals negative 3 plus 5y into equation 1. And I'll write equation 1, but I'm not going to have x anymore. I'm going to have what x is equal to. So it goes 2, not x, but it's going to be negative 3 plus 5y plus 3y equals 7. Okay? I'll multiply my 2 in, so I'm going to negative 6 plus 10y plus 3y equals 7. I'm going to have 10y plus 3y is 13y equals 7. Take my minus 6. I'm going to add 6 to both sides. So it's going to be 7 plus 6 on that side. 13y equals 13. Divide both sides by 13. Y equals 1. I found the y value. I need to find the x value. I need to find both coordinates. So I'm going to sub y equals 1 into equation 2. I chose equation 2 because it had already been rearranged to have the x by itself. I could put it in equation 1. It does not matter. Choose whatever one's easier. So I want to find x. I already have x by itself in equation 2, so let's put it in there. X equals negative 3 plus 5. It's not y anymore. We know what y is. Y is 1. X equals negative 3 plus 5. X equals 2. So therefore, my x and y coordinates are equal to 2 and 1. And that'd be the point of intersection between these two linear relations. A short little lesson on substitution. Thank you very much.